Okay, let's go.
Kinematics define and use distance displacement. We'll know from this chapter. From this lecture, we'll know kinematics equation of motion. Candidates should be able to define and use the distance, displacement, speed, velocity, and acceleration. Use graph methods to represent distance, displacement, speed, velocity, acceleration. Determine displacement from area under a velocity time graph. Determine velocity using the gradient of a displacement time graph. Determine acceleration using the gradient of a velocity graph derived from definition of velocity and acceleration equation that represent uniformly accelerated motion in straight line. Okay, and solve problems using equation that represent uniform accelerated motion in a straight line, including the motion of bodies falling in a uniform gravitational field without a resistance. Describe an experiment to determine the acceleration of free fall using a falling object. Describe and explain motion due to uniform velocity in one direction and uniform acceleration in a perpendicular direction, guys. First on distance and displacement. Distance is the total length of the path traveled by an object. Distance is scalar quantity, unit meter. One ball is traveling from A to B. Distance here A to B, half of the circumference. This is the total circumference. Okay, this is total. So this is the distance. Okay, and half. This is half of the circumference. And displacement, magnitude, direct distance from A to B. Here, this distance A to B. This is actually displacement. Okay, and diameter of a circle. Direction from A to, this is the direction from A to B direction. Okay, downward south. What is displacement? Displacement is the directed distance from the start to the end points. Here, directed distance. This is directed distance, and from the start to the end points is vector quantity, unit meter, and ball travels from A to B. Okay, A to B. This A to B and or A to B. Okay, this is actually displacement. A ball travels from A to B to A. Distance, magnitude, circumference of the circle, displacement 0. Okay, if any object goes from A to B and goes back to A, then displacement will be 0. But distance, here distance will be this full circle. Okay, speed. Okay, speed is a rate of change of distance. Speed is a rate of change of distance. Distance is related to speed. That means speed is related to distance. Yeah, look, initial velocity u and time 0, final velocity v, final velocity v, final velocity v, total displacement moved second. Car is traveling with a constant acceleration. Here we are learning speed. But is velocity u plus v upon 2 equal to s upon t. Total displacement moved, and that means here speed is the rate of change of distance. Distance is related to speed. Velocity is the rate of change of displacement. Displacement is related to velocity. Velocity is related to displacement. So it means meter per second. Sign plus minus in front of the velocity indicates direction of the object motion. Okay, and magnitude of velocity is equal to the speed. Magnitude same, but one object travels in a straight line. In straight line basis, magnitude same. Magnitude same. Magnitude of velocity is equal to the speed, but and does not change its direction. Does not change the direction. Straight line. When you think about this, then this This car is going with u velocity along this straight line. Here, the magnitude of velocity is equal to speed. Okay, and this direction doesn't change. A car is moving with the constant speed here, and car's velocity is not constant. Is not constant. Here, speed is constant, but velocity is not constant because this path is not a straight line. This path is not a straight line. It is curved, but that's why direction is changing. Direction of the car is changing. That's why velocity is changing. Velocity here is not constant. Now, acceleration is the rate of change in velocity. It increases meter per second square. Final velocity v, initial velocity u minus upon t. This is the formula of acceleration, and we knew from the IGCSE. From this equation, we could write v equal to u plus at. Okay, rearranging, and the formula is used for only constant acceleration motion in a straight line, where while in the vehicle to you the meaning the acceleration zero. If velocity equal, the velocity is zero. Change in velocity minus meter is constant velocity here. Change in velocity, when change in velocity is zero, then we will say it is constant velocity. When v greater than u, meaning that acceleration is positive. When v is greater than u, then acceleration positive. Increasing velocity, accelerating. When b less than u, then we'll say acceleration is negative. Here, positive and negative we have to think. That means decreasing, and that is decelerating. Okay, that is decelerating. Okay, fine, guys. Now, motion graphs, displacement time graph, displacement and time graph del s del t. We will get gradient del s del t v, gradient velocity. Area under graph has no meaning. Here, this area has not any meaning. Okay, and velocity time graph, here velocity and time. Okay, let me take another color. Actually, this is time, and this is velocity. This velocity time graph del v del t. This is the change of velocity. This is the change of t. That means gradient. This gradient del v upon del t a, that is acceleration. Okay, velocity method here, initial velocity u, final velocity v. Area under graph, average velocity u plus v upon 2 to t. Area graph displacement move. Here this area is displacement, and we have got by the average velocity u upon u plus v upon 2 time here t. Okay, this is the time and this is the velocity, and from this velocity we have got this. Okay, okay, now it's very technical and a bit tough. We have to realize this from the okay. here this point gradient is increasing, velocity increasing. This is the s and time graph. Okay, when we consider displacement and time graph, we will get velocity. Here velocity is increasing, here velocity constant, gradient constant. This point gradient constant, this point gradient decreasing, velocity decreasing, gradient zero, gradient then zero velocity, this one zero velocity, this point increasing, negative increasing, gradient velocity increasing, that means in opposite direction, negative constant, opposite direction, and negative decreasing, gradient decreasing, velocity in opposite direction, this point. Okay, this point, and from this graph, this figure, we will draw this graph will draw. Okay, this graph will draw. Clear? Here, here, okay, from this we will get this. Okay, here zero, here gradient is zero, and gradient is increase, this point gradient is constant, and zero gradient here, and negative constant gradient, and this one negative constant gradient, and look here, this zero gradient, and here constant gradient. Look, this point is constant gradient, and this also constant gradient, and this is a zero gradient, so this is zero, this also zero, and this zero, and this is opposite direction, so we can draw like this way, this point, and from this point, and this zero gradient here. Okay, zero gradient and zero gradient here, zero gradient, constant gradient, constant acceleration here, it is the zero. Displacement movement, here displacement, displacement here, displacement move to left downward. Okay, velocity change, the sign, the motion direction will change, guys. From this point we have got this point, and this section is increasing, that's why it's increasing. Here constant, here constant velocity, here constant velocity, this constant. Okay, and for this line we have drawn this. Okay, and for this point we have this point, and for this point we have done in here, this is zero. Okay, and now this section, for this section we can draw this section, and here actually constant, we guess this is constant velocity, again is decreasing. Okay, that's why this decreasing line, and zero line, this is also why we can show this. Okay, guys, and now look here, constant, here constant acceleration, zero acceleration, constant acceleration, and this is zero acceleration, and like this way we can draw constant acceleration. That means this is the acceleration time graph. Okay, yeah, velocity time graph, but here acceleration time graph, acceleration time graph. Okay, so for this constant section we can draw, what can we draw? we can draw this is constant, okay, and this is 0 acceleration, so this line, okay, and for this section this is negative. This is negative actually, and this upper side is positive, okay, and this section 0 acceleration, and this section is 0 acceleration, and for this section this is actually acceleration, and this is constant, that's why, or this is constant, this for this line, again for this section this line, and for this section here again positive. Look here positive, okay, here positive, again upward, increasing, okay, decreasing, constant, increasing. Positive acceleration, negative velocity, positive acceleration, negative velocity, opposite direction, so speed, okay, this is time, this is acceleration, okay. We understood what I have said. From this line we have got this, okay, and I have said different portion of this graph. Okay, practical example, exam style question here. Here you can see variation with time t, the velocity of car is shown. What is the average velocity? We have to find the average velocity, okay, of the car for the journey shown by the graph. Here velocity, here time, okay. This is time, that's why, and this is actually constant acceleration. This is velocity time, there's a velocity. This is the variation of the time of the velocity of the car. What is the average velocity? We have to find out the average velocity, and total displacement we have to find out. Here area 6.0 into 360, where the area 3 into 10, what is 3 from this 3, and 10 this, okay, that's the area this, and here this section is 5, okay, and 0.6, where we have got 0.6, so this is 0.6, and that's why we have written 0.6, and 0.6 means velocity. 0.6 means velocity for this section, okay, for this section velocity, and what is the time? Yeah, so time, what is the time? Where is the time? Okay, time means this difference 10 to this is the time, okay, and this is the the direction, this direction 6 is the velocity, that means we get minus, yeah, velocity means minus sign, okay, and this area 30, and this area 30. Total displacement, here total displacement is 0 because 30 is 0, and total time 15, that means 0, but area under graph displacement is 0. Displacement here 0, and a mass on the end of a spring bounces up and down as shown after being released at time t equal to 0. Sketch the graph of velocity varies with time. Time t0, here displacement up, displacement down, displacement up, gradient 0, velocity 0, maximum gradient decreases, velocity decreases, here increases, okay, gradient increases. Why we have done this? Where we written the distance up, distance down, here down, okay, down up, down means starting point here, okay, and going up, and from this figure we have got this velocity up, velocity down, here gradient of displacement of velocity. We can start from 0, and from the positive plot and negative, such way you can draw the graph for this spring.